Okay, so let's use the long division of a polynomial by a binomial with word problems. So the volume in cubic meter of a rectangular box is given by v of x equals to x cubed plus 7x squared plus 14x plus 8. Determine expressions for possible dimension of the box if the height is given by x plus 2. So remember what we have here. We have a box, right? We know its volume. We know the height. Now what I'm trying to find the other two dimensions. All right. So we know that the volume of a box is length times width times height. I know the height. I know the volume. I'm looking for length and width. So that technically tells me that I need to divide. If I divide the volume by the height, then what I have left is the length times the width. So let's see how that works. So I have the volume, which is my dividend, and I'm dividing by the height. So x cubed divided by x, that gives me x squared. X squared, so if I do the multiplication, x squared times x is x cubed. X squared times 2 is 2x squared. Can do the subtraction here, and I'll be left with 7 take away 2x, 7x squared take away 2x squared. That's going to give me 5x squared. Bring down the 14x. And now if I divide 5x squared by x, that's going to give me 5x. 5x times x is 5x squared. 5x times 2 is 10x. And now we're going to do the subtraction. That's now going to eliminate 14x, take away 10x. That's 4x. And finally, bring down the 8. If I divide 4x by x, that's 4. And I'll be left with 4x. If I multiply 4 by x, that's 4x. 4 by 2, that's 8. And you see here, if I do the subtraction, I'm going to end up with a remainder of 0. Perfect, because I need that. Because what's going on here is I know that h is a factor, right? So I know that I'm going to have factor times a factor times a factor. I shouldn't have any remainder left. So let's see what we have here. We have the following. So we have the volume, which is x cubed plus 7x squared plus 14x plus 8 is equal to, we know the height, which is x plus 2, and we know that the quotient that I just got there is x squared plus 5x plus 4. So here's what we have. We have the volume, we have the height, and this is the area of the base. So I can factor this. This is a quadratic. This is easily factored by sum and product. So I'm looking for two numbers that multiply to 4 and add to 5, and that would be 4 and 1. And that I can right away write it as x plus 2 times x plus 1 times x plus 4. And you remember what I told you above, that length times width times height. I know the height, and these could be my length and width. Okay, so the dimensions or the possible dimensions of the box are x plus 1, x plus 2, and x plus 4. Okay? Now, the remainder theorem is related to the division. The remainder theorem helps us a lot because the remainder theorem tells us if what we've done with respect to the long division is correct. because I can test to see if I know what my divisor is. I can test that divisor. I can test that. Um, so let's say if your divisor is x minus b, if I plug in b into my polynomial, whatever that answer is, that should be your remainder when you do your long division. So let's look at this example. What I have here is I have my polynomial is px equals to 2x cubed plus x squared plus minus 3x minus 6, and is divided by x plus 1. I want to know what the remainder is, okay, by applying the remainder theorem. So I don't want to do the long division. I just want to apply the remainder. So what I need to do is I need to set that x plus 1 equals 0, which is x equals negative 1. And I need to find what p at negative 1 is equal to. If I can find out what p at negative 1 is equal to, that is the remainder of the division. So I plug in negative 1 in for x, so that will be 2 times negative 1 cubed plus negative 1 squared minus 3 times negative 1 minus 6. So what I'm doing here is I'm replacing whatever the x is with a negative 1. So it's going to be negative 2 plus 1 plus 3 minus 6. So if I calculate this, that's going to be negative 4. So that means the remainder is negative 4. So if I do a long division and I divide this by x plus 1, you can try that. You should get a remainder of negative 4. Let's verify the answer. Okay, let's do that. So 2x cubed plus x squared minus 3x minus 6, and I'm dividing by x plus 1. 2x cubed divided by x, that's 2x squared. Now I multiply 2x squared by x, that's 2x cubed. 2x squared by 1, that's 2x squared. Subtract, so that's going to be x squared, take away 2x squared, that's negative x squared. Bring down the negative 3x. So if I divide negative x squared by x, that's negative x. Now multiply negative x by x, that's negative x squared. And negative x by 1, that's negative x. Subtract, and I will get negative 3x, take away negative x, so that's going to be negative 2x, and bring the negative 6 down. If I divide negative 2x by x, that's going to be negative 2. Negative 2 times x, that's negative 2x. Negative 2 times 1, that's negative 2. And if I do the subtraction, I'm going to end up, I'm just going to write it here. So negative 2x minus negative 2x, that's 0. Negative 6, take away negative 2, that's a negative 4. So the remainder is negative 4. Is that the same answer that we just got in the previous slide? The remainder of negative 4? Yep. So what I had to do, if I just want to find the remainder, all what I have to do is I have to plug in the factor. So in this case, if it's x plus 1, you're going to plug in negative 1 into x and calculate to find the remainder. Let's look at this example. So use the remainder theorem to determine the remainder when p of x, which is 2x cubed plus x squared minus 3x minus 6, is divided by 2x minus 3. Remember, in order for me to find the number, I have to set up my divisor equal to 0 and find x. So x in this case is equal to, so 2x equals 3. X is equal to 3 over 2. So now I need to find the remainder. So to find the remainder, what I have to do is I have to plug in 3 over 2 in for x. So let's see how that's going to work. So I'm plugging in 3 over 2 for x. So first of all, I have to do the exponent. So that's going to be 3 over 2 cubed. That's going to be 27 over 8 plus 9 over 4 minus 3 times 3 over 2 minus 6. Now I'm going to multiply and simplify each term. So that's going to be 2 and 8. They're going to simplify to 27 over 4 plus 9 over 4 minus, in this case, I can't simplify, so it's going to be 9 over 2 minus 6. I have to have a common denominator because I'm adding terms. So my common denominator is going to be 4. And it's going to be 27 plus 9. And then to multiply this to make it 4, I have to multiply by 2. So it's going to be minus 18. And this one I have to multiply by 4. That's going to be negative 24. And the answer for this remainder, so the remainder here is going to be negative 3 over 2. So therefore, the remainder is negative 3 over 2. All right. Let's look at the last question. So this question is saying determine the value of k such that when 3x to the power of 4 plus kx cubed minus 7x minus 10 is divided by x minus 2, the remainder is 8. So if I use the remainder theorem, if I plug in 2 into my function, what should it equal to? It should equal to 8, because remember that p at 2, right? Because it's giving me that the remainder is 8, so p at 2 is equal to 8. So what I have to do here, I have to plug in 2 in for x and equal it to 8. So 3 times 2 to the power of 4 plus k times 2 to the power of 3 minus 7 times 2 minus 10. I know that this is going to give me the remainder of 8. So if you look at this, it's all numbers except k is the only variable. So we're going to solve for that k. Let's do that. First, I'm going to have to get rid of that, the exponents. 2 to the power of 4, so that's going to give me 16. 16, so I have 3 times 16 plus 2 cubed, that's 8, so that's 8k minus, I can do that 7 times 2 right away, so that's 14 minus 10 equals to 8. 3 times 16, that's 48 plus 8k, and I can add these two together, so that's minus 24. Let's collect like term. 48 minus 24, that's 24, so that's 8k plus 24 equals 8. Bring the 24 over, so I have 8k equals to 8, take away 24. So 8k is equal to negative 16. And the last step is to divide by 8. And that's going to give me a k of negative 2. There you go. So if I plug in here, instead of having 3x to the power of 4 plus kx cubed, if I have a minus 2x cubed, minus 7x minus 10, And if I plug in 2 in for x, I'm going to get a remainder of 8. You can try that and see if that works. All right, that's it for this lesson. I will talk to you guys again in the next lesson.